All right, so it is halfway between 9 p.m. and 10 p.m. on the East Coast, which is where I am coming from tonight. So welcome to the Global Math Department, everyone. My name is Lee Natero, and I will be your host tonight. Tonight, we're going to be hearing from Graham Fletcher about building fact fluency through virtual storytelling. Would everyone please introduce themselves in the chat window, telling us what you teach, where you teach, and what your Twitter handle is if you have one. I'm glad to see that we have so many people here from not just around the United States, from East Coast to West Coast, but we are truly global tonight as we have people from the Philippines and Canada, our neighbors to the north. Welcome, everyone. So sharing in the chat what you teach, where you teach, and what your Twitter handle is if you have one. So before I introduce our speaker, let me explain how these meetings work. These meetings are recorded and are available within 24 hours after the meeting ends. To view the recording, you can use the same URL you used to get here tonight. We also post the recordings of these sessions on our YouTube channel, and fairly soon they will also be closed captions. We have some people that are going to be editing the captions to make them accessible to everyone. The Global Math Community prides itself on being friendly and supportive. The chat room is available for topical and general conversation throughout the meeting. I'll catch your questions for the presenter, so don't worry that the presenter won't notice your question in the chatter. Our speaker tonight is Graham Fletcher. Graham has served in education as a classroom teacher, math instructional lead, and he is currently a math specialist. He is continually seeking new and innovative ways to support students and teachers in their development of conceptual understanding in elementary mathematics. Graham's work with the math progressions and problem-based lessons has led him to present throughout North America and beyond. He is the author of Building Fact Fluency, a toolkit for addition and subtraction, and openly shares many of his resources at gfletchy.com, which you can see is listed on his introductory slide. So I will turn our meeting over now to Graham.
Awesome, Lee. Thank you so much, Lee, for putting this together. Thank you to Global Math Department and the University of North Carolina State University for hosting, and most of all, thank you to you wherever you are in the world. I've seen Philippines, I've seen Hong Kong, Australia, my home country, Canada. Even here, I now live in Atlanta, Georgia, and I even see people from my own state here. So thank you. Wherever you are in your world right now, you chose to hit pause, come hang out with us for the next 45 minutes, 50 minutes, just around fact fluency. And we're going to dive into this. It's going to be kind of like drinking from a fire hose is the best way that I can kind of explain it myself. So buckle up. I'm really excited. One thing I'm going to ask that you do, Lee did a really good job of setting up this chat window. This is going to be where you and me get to kind of interact with one another. In a webinar, it can seem very one way. I'm not a one-way kind of thinker. So I'm going to throw questions at you. I've got another monitor over here, and I'm going to ask that you throw in the chat window, and that way I can see what you're thinking wherever you might be in this wonderful world that we live in. So thank you. But let's not waste any more time. Let's kind of dive in. One thing before I get started is we're going to share the slide deck with you. So you're going to see things today that you're going to be like, whoa, I love that. And you might be trying to frantically copy out notes. Pause, don't hit notes, don't start taking notes at all. I would much rather you engage in conversations in the chat window and just kind of soak in what we're doing. I'll send you the slide deck and then you'll have another opportunity to look at it. Don't worry about taking the notes. Think about your ahas, but let's kind of dive in here. So your journey and why you are here, like you saw the session title, Building Fact Fluency Through Virtual Storytelling. And even if it wasn't in a virtual space, like you see fact fluency and it immediately piques your interest. Over the last 8-10 years, I've had an opportunity to work with grade levels from kindergarten through like 10th grade. And I'm going to be completely honest. Once you get out of like first grade, the one complaint or the one kind of like grudge that teachers always have is my kids just don't know their facts. And so it doesn't matter what we do. Like there's always a big, probably larger group than there should be of students that don't learn their facts. I think about my time when I was a student, like my dad would ask me to do the flashcards. And if I didn't do the flashcards quick enough, he'd be like, Graham, you need to memorize harder. Like, let's hit pause for a second. Like, memorize harder. Is this even possible, Dad? But, you know, kids in the old days, we didn't question our parents. Memorizing it harder is impossible. But that seems one of those practices that we've brought along the way here when we start looking at fact fluency. So you're here, and why you're here is you've had that fact fluency feeling before, and you're like, what is the fact fluency feeling? You know, when you've been working on fact fluency for like 3-4 weeks, or maybe like 5 weeks, a full unit, and you're just frustrated. Your kids leave the classroom, and you have this feeling here. Right? We all have had that feeling. All of us, every single one of us. So one thing I really want to do here is before we even get started, you all are the experts. You all are brilliant at what you do. And I want to kind of leverage and call out to you here and say, hey, help me out here. A parent walks into your classroom and says, you know what? I've seen all of this about fact fluency. Like, what is fact fluency? Help me out here. So I'm going to sit tight for about 30 seconds in the chat window. If you can, type out, like, what is fact fluency? Like help me out here. How would you explain it to a parent? Like 2 or 3 words, quick 2 or 3 word elevator pitch. What is fact fluency? Throw it in the chat window for us, please. What is fact fluency? Nice. And I'm seeing lots of you jumping in here, thinking flexibly, automatic, knowing facts with automaticity, lots and lots of terms. And you know what? It all comes out to, it's kind of the same thing. But to be honest, even if all 800 people showed up in this webinar right here, we would get 2,754 different definitions for what fact fluency is. Like it's one of those things that's hard to cast a net around. And so what I like to do when I start thinking about this is like, where have we thought fact fluency was in the past? And we have a lot of students who we think are fact fluent, like they know those facts. But this is how they end up in math class sometimes. This is kind of evident. Those kids that know their facts, yeah, maybe you've seen a student like this.
Hi, what's your name? And how old are you, Nanny? 2. What's 1 plus 1? 2. Okay, what's 3 minus 1? 2. What's 10 divided by 5? 6. What's the square root of 4? 2. Very good. And what's 1,210 minus 1,208? 2. Good job. One more. What is 1 times 2? 2. That's right. So you did your addition, subtraction, multiplication, division. 2. How old are you? 2.
Right? Like we have those students in all of our classes, those students who quote unquote are fact fluent, like they can regurgitate facts and number computation. But when it comes to problematic, like problem solving, they really hit a bump in the road. So for too often, what I've seen is like fact fluency is a standalone skill that we'll use and call on whenever we need it, but we never really try to leverage that anywhere else. So that's kind of where I want to go. And when I want want to find out what is the best way to approach fact fluency, we want to go to what the research says. So here is adding it up from the National Research Council. I'll give you about 10 seconds to read this here just to kind of refresh, because I know you've read this. Yeah, I'll give you about 10 seconds here to read this. So there's adding it up, the National Research Council. Here's the next one, Principle to Action from NCTM. Really, I've leaned a lot on this in the last few years. I'll give you about 20 seconds to read this here. This will help guide us moving forward. So there we have Principle to Actions with from NCTM. And then the last one, these are just the 3 big pieces of research I'm going to kind of lean on today. I'll give you 10 seconds to read this here. And I'm loving the fact that I can see back channel talk going through the chat window, which is perfect. Keep it going, grow and learn from one another as I'm kind of chatting. So I start thinking about this, like when I look at all 3 of those terms, and even when I'm looking in the chat window and you yourself are defining fluency, like these terms, accuracy, efficiency, flexibility, like they all get brought up, whether we're talking about research, whether we're talking about like presenting in your curriculum, these terms always get brought up. Now maybe you've never heard these terms, but here's what they are at like a 60,000 foot view, the simplest way that we can explain these. So accuracy is finding the right answer. Finding the right answer is important with fact fluency. It doesn't need to be the lone piece though, but for too long, many of us we learned our facts as accuracy is the be all end all. But it also includes efficiency. So that's the ability to solve a problem with a strategy that saves time or labor. Like counting strategies are fantastic within 10 when kids are developing that understanding of number. There's nothing wrong with counting with fingers or counting on. But if you have to count on when you're adding 109 plus 352, that sucks. That's going to take a really long time to do. And then the last one is flexible. So you have multiple ways to do it. So maybe if you might think of doubles plus 2, doubles minus. If you forget to what 8 times 7 is, do you have another strategy to kind of get there? So that flexibility. So fluency, fact fluency means that students know their facts. And we have a lot of students in our classrooms that know their facts. Now, granted, we have a group of students who don't quote unquote know their facts, but we have a heck of a lot of students in our classroom that don't know how and when to use those facts. So think about when you pose your students a problem and they don't know if it's multiplication or division. Think about when you pose them a problem and they don't know if it's adding or subtracting. They know the operation, but they don't know which operation. They know how to apply the operation, but they don't know which operation to choose. So I want to go back to these definitions really quickly and highlight something. Accuracy, efficiency, and flexibility. It's in this definition. But where I overlooked for so long was this piece, the knowledge of when and how to use them appropriately. All right. Okay. Well, let's go to the next one. The principles to action. What did they say? Well, they say that fact fluency, we should be able to solve contextual and mathematical problems. All right. So normally when I think about fact fluency, I think about like naked numbers. I don't ever think about it in a context, like in a word problem. Okay. All right. So I'm not really thinking about that. I am now. And the last one, procedural fluency in mathematics, another one from NCTM, different problems and contexts. So what's really helped me grow here in the last little while is I've recognized, and research has supported for years, and maybe I just wasn't listening, but there's a huge piece missing when we talk about fact fluency. It's not efficiency, it's not flexibility, it's not accuracy. Yeah, we're missing those in a little bit, but we're really missing the contextual piece. And that's really what I want to talk about today. So here's what I got right and here's what I got wrong about fact fluency. Any of you who have been teaching for anywhere longer than 8-9 years, you know that there's been and then beyond 20 years, like there's been a huge push for number talks and number strings in our classrooms, and I love them, and they were a beautiful tool. But what I realized is I would get really frustrated with my students. Let me kind of explain. I would do number talks with students, and we would use like 9+6 in a first grade class. And those kids would rock their strategies. Like they'd know 9+6, and we'd have kids who would take the 1 from the 6, give it to the 9 to make a 10, and they would add 10 plus 5 to get 15 for 9+6. They know that make a 10 strategy. But the second that we weren't in number talks and we'd be working on some kind of math problem, they would revert right back to counting strategies. And what I realized is that there was a disconnect between the efficiency, the flexibility, and the accuracy and the context. I was teaching the two of them in isolation of one another, and that was never getting me to meaningful fact fluency. Let me kind of give you this image that will help explain. So like here you have a bolt, and if this bolt is the fact fluency, it's the accuracy, the efficiency, the flexibility. This bolt cannot be anchored down to anything because right now it has nothing to screw on. So when I think about how do we make this accuracy, efficiency, this flexibility bolt meaningful, well, we have to attach it to a context. So if you don't have that nut, that context nut, you have nothing that we can attach the accuracy, efficiency, and flexibility to. So the nuts and bolts of fluency are not just accuracy, efficiency, and flexibility, but they're also context. So before I go any farther, I want you to think about you in your own practice, whether you're in a K2 class, a 3-5 class, or middle school or high school. Think about how we are engaging students in fact fluency. Is it naked numbers out of context? Well, if so, we're missing a really key piece. Because fact fluency should be an outcome of meaningful problem solving with purposeful practice. And I'll be honest, I was missing the boat for so long. So, when you come to teaching fact fluency, you probably want to jump online and you want to start going and searching. And you're looking for like virtual math cards. You're looking for anything, especially in this virtual space. Like, what do you do? And I want to stop you like right there. Nothing is going to show up because this doesn't get us to fact fluency. What gets us to fact fluency is context. So that's where I really want to spend the latter part of this session talking about. I want you to think about how we can really invite context into the classroom that will help support the mathematical fact fluency that every single one of us are after. So here is how we're going to start in 3rd and 5th grade, and then we're going to drop back down to our primary grades. So here's how I would kind of start. In the chat window, I'd like for you to just type down, what do you notice as you watch this video here? In the chat window, go ahead and type down some things. What do you notice as you watch that video there? Yeah, Diane, you've been to the patch before, right? Like they charge you like almost like $4 for every peach that you pick. Yeah, they are Georgia peaches for sure. No blueberries. Kenny, good to see you, my friend. Yeah, absolutely. No blueberries. Yeah, you all are all over this. So what we're doing here is we're kind of engaging in a 3-act task. Big shout out to Dan Meyer for creating 3-act tasks, the originator of them. Nobody was really creating them for elementary, whereas I fit into this whole space. But yeah, shout out to Dan and his work with 3-act tasks. Thank you for blazing that trail for us. So noticing lots of different things here. So the question, so you've noticed a whole bunch. What's the question that I'm after here? As you look at this big box of peaches, what's question? What do you want to know? Yeah, Holly, spot on. Like, it is hard to count how many peaches are in there. Absolutely. What would you like to know? What are you wondering? Does it weigh 10 pounds? Okay. How many peaches? Yeah, and so for the sake of time here, we're looking at like how many peaches are in the box. That's kind of our question here. So we've already done the notice. I don't want to dive too deeply here into 3-act tasks, but this is what we're using to launch this idea. So you've noticed, you've done the wondering, and now we're trying to figure out like, how many peaches are inside that box right there? So here's the thing. If I was to ask you what an estimate is, every single one of you would probably call it, it's an educated guess. Well, I don't want kids looking at that box of peaches and guessing like, I don't know, like 4, 5, like, no, I don't want you to guess like 150. Like we all get those 5 and 6-year-olds that would guess that many. So what I want you to do is in the chat window, come up with an estimate, but I don't want you to guess. I want you to take like 30 seconds and come up with an estimate. And an estimate is not an educated guess. It's a strategic choice of a number. Go ahead in the chat window, throw down your strategic choice of a number for us. Like how many peaches are inside that box right there? Yes, loving this right now because it is scary for you folks, right? Like here you are, you put in your number and you hit enter and you are committed. Like if you're scared of commitment, that chat window can be a really, really scary place for you. And so, yeah, we're kind of locked in. I see ranges. I think I saw 21 might be the lowest I saw. 45 might be the highest. Yeah, it is in that range for sure. So here's what I'll do. We want to come back and now you need a little bit more information from me. So I'm going to share this with you. Like we're at the peach farm. The peach farmer goes and they pick the peaches and then they have to put them inside these individual little baskets. So in each one of these baskets, you can see that there are 4 peaches per basket. And what's nice is even though we're talking about multiplication here, think about this idea of unit rate that we're actually building because the context is so rich. We have groups of groups here. We have one group of a basket, and within each one group of a basket, we have 4 individual peaches. So we're getting at that unit rate, which is a beautiful, scalable thinking that can help students learn and grow moving forward. So now you know that there are 4 peaches in each basket. You want to know how many peaches are inside that big box. I'm going to give you this information here. I'm going to ask that you just don't type in the answer. You all are rocket scientists. You'll get the answer, no problem. I want for you to please type an equation or just a sentence that kind of explains how you found, I'll say the product, but really it's also the total sum of peaches. That's how many peaches are inside the of the big box. How are you solving that? Throw something in the chat window for us, please, not just the product. Awesome. So again, thank you. It means a lot to me that you all are jumping in on the chat window and kind of sharing. So there's a couple thinking, right? Like most of you look at this and you're like, oh, it's 9 groups of 4. And when you think about it, like 9 groups of 4, that kind of like, that might suck to try and do mentally. So some of you immediately leverage the commutative property. You're like, I don't like 9 groups of 4, but I know what 4 groups of 9 is. I noticed like Nicole has 4 times 3 times 3. I noticed Melissa has the same thing, 4 times 3 times 3. Arlene has 2 times 2 times 5. And what's nice is just because of this visual, some of you have leveraged the commutative property, but some of you are also leveraging the associative property, and some of you are now also leveraging the distributive property. I think I saw the distributive property. I might have missed that one there. But the big piece here is these properties. They normally don't really get brought up when we talk about fact fluency. It's like, let's learn our facts first, and then we'll go ahead and we'll talk about the properties after. So I want to front end load this idea about building fact fluency with context and also with properties. So you've kind of done the math here. You get to play along in that space. And now you want to know, like, hey, how accurate am I? Like, was I able to figure that out? And there you go. So 36 peaches. So this is a 3-act task, and I really like using these tasks. First of all, kids get engaged, but it's not for the reason of engagement. It's for this reason. I really like to use a high yielding task, such as a 3-act task, because I see them as anchor tasks. And what an anchor task is it's a task that builds and leaves mathematical residue. And you're like, what? Like, what is this term, mathematical residue? Like, I've never heard this. Where is it coming from? So this term, math residue, it comes from James Hibbert's book, Making Sense, from a group of wonderful authors. And I'll give you kind of a second here. Like, what is important is that context of tasks allows all students entry into the situation, allows students to problematize the situation. Every student in your class could notice a peach. Every single student in your class could estimate, whether it was a good estimate or an off estimate. They can notice the white box. No matter of their ability, every student is invited to the math conversation here. So now they can get invested into this problem. And so I want to ask you right now, from that task that we just did with peaches, that 3-act task, there's things that are still resonating with you right now. They've left a little residue in there. I'm going to sit tight for about 15 seconds in the chat window. Type down everything that you just remember about seeing the peaches task. What do you remember? Four in the small basket. Yeah, thanks, Lee. Somebody was picking them. They were at a farm, operations, properties, baskets, arrays, smaller groups. You can have units and units, organizing groups. Yeah, like there's a whole lot of things. Kids are going to remember that the basket was green, the checkered tablecloth. Like they're going to notice the most non-mathematical things. But what's beautiful about that is they have something that they're remembering that I can now pull out and invite them into the next conversation. Yeah, I love the chat window kind of blowing up here. So now that we have this image of 2 young ladies going to the peach farm, pulling out the peaches, now we could start off with this. Well, you look at this image and you see, oh, okay, well, you have 1 box of peaches, like 1 carton of peaches. So you know that's 4. All right, perfect. So that's the first image that we'd see. Then I follow it up with this image here. Interesting. Okay. So now you can see that we have 2 times 4. All right. And you could also see it as 4 times 4. Or sorry, you could also see it as 4 plus 4. So we have 1 times 4, 2 times 4. Interesting. in the chat window, make a prediction. What's the next image going to have? Let me go through it again. And I'd like for you to, this is what we call like an image talk, kind of like a number talk, kind of like a number string, but it's not using numbers. It's leveraging images. So let's go again. We have 1 times 4, 2 times 4, 4 times 4. What comes next? Yeah, Michelle, spot on, right? A double, double, double. And when you're thinking double, 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 if you think of the distributive property, like how do we want kids to know their eights? Like we don't, like kids are going to sit there and they're going to go 4, 8, 12, 16, 20, 24. Great when they're building that understanding. That's that additive thinking. But just like Michelle just shared, we want students to see that 8 as the double, double, double. I double my 1s, I double my 2s, I double my 4s, and I get to my 8s. And then when you see this last image, how can you count these peaches up? Now, throw an equation in that matches your thinking. Might be a little bit different than what you did last time. Nice, Melissa. So you're using your 5s and your 3 facts, okay? Sheila's using the distributive property. You're going 4 times 6 and then plus 4 times 2. Yeah, Gigi, you're absolutely right. Kids will stop counting and start wondering, like, are all the peaches the same size? And so, yeah, we'll have that conversation because when kids would typically ask, I wonder if all the peaches are the same size, we would tell them that's not important. But for a student, that is important. And we could recognize that they're not all the exact same size, but at least they're roughly the same. So really inviting that curious conversation to the math table is a big piece. So yeah, I noticed a lot of us now are using the associative property to figure this out. So here's what I've really realized in this virtual storytelling is these images, these big, bright, vibrant images give students greater access to the multiplicative thinking. Like if you just show them numbers, a lot of students are going to kind of like shy away because those numbers might not be so inviting to some of them. But if they see those groups of groups, then they're now willing to think and share a little bit more about their thinking, about their reasoning. And to be honest, I think that's what every single one of us in this session is looking for. So here is a visual that I absolutely love. It is from Pam Harris. I've been leaning on it now for quite some time. It's about developing mathematical reasoning. And what this does is it looks at learning mathematical reasoning from like a 60,000 foot view. And what I realize is that we want a lot of our 3rd, 4th, and 5th grade students to think multiplicatively. But we've never had them move from counting to additive strategies. And then think about that functional reasoning that needs to be taking place in middle school with like our 14s and 15s and 16-year-olds. A lot of them struggle with the functional reasoning because they don't have that multiplicative or that proportional reasoning. So a lot of the times when I'm trying to find out where student thinking is and how I can move their thinking forward from that skip counting to that multiplicative, I have this image resonating in the back of my mind. So I just want to kind of share this with you. A big shout out to Pam Harris for sharing this. It's kind of like a framework for me from a 60,000 foot view. It helps me think of my next question in the moment. Like, how do I move them forward? Not answer getting. If their thinking's right, how do I move their thinking forward? Not necessarily the right answer. And then I could come back and share another image. All of this is grounded in the context of peaches. Like, what's the same? What's different here? And you might attack these two problems completely different in the chat window. What's the same? What's different? I'm going to sit tight here for about 20 seconds. What's the same? What's different? Please go ahead and share. Yeah, spot on. And if I was to ask you to go ahead and tell us how many are there, you'd probably have two completely different ways of approaching how to find the total number of peaches here. And so just thinking about this, how much are we inviting these conversations into our classroom for our students? Yeah, lots of thinking here. Love the same different chat kind of going on here in the chat window here. So I want to kind of share this, and because I'll be honest, I taught third grade for 8 years, and what I've realized since in the last 12 to 13, 14 years is that the properties, well, there are mathematical superpowers. And a lot of students don't realize, and even teachers, we don't realize how powerful these properties can be. Think about if Superman was never told that he could fly. Like, he wouldn't be Superman. And how many times are we grounding our students' thinking in classroom because they don't know how to leverage those properties? So I really want to challenge and invite you to use context as much as possible as you begin to build fact fluency and interconnect and intertwine the two of them. It's about decontextualizing and recontextualizing the numbers. Now, unfortunately, everything in life doesn't come in boxes of 4 peaches. So now we have to start making connections for students. So just like we took those 4 images of peaches and used a number string with an image talk, we would use a rec and rec to kind of pull out some more of that thinking. And as you start looking at this, well, you immediately start seeing, okay, so 1 row of 4. That's the first image. Third graders are going to get this pretty straightforward. But then you'd show this image. Whoa, now we have 4 rows of 1. So like, what just happened there? Is it the same? Is it different? Well, it is the same and it is different. And you know, like, the commutative property is screaming at you. But when students see this 4 or this 4, they're thinking of those peaches. They're now grounding their understanding in peaches because that 4 now has meaning for them. And then again, we're pulling out the commutative property. So again, we're connecting tools with context. It's not just, it's trying to connect and make as many relationships as we possibly can. And then here's another one, another tool talk. Same thing. It's images being used as number strings to pull out those rich mathematical conversations that we normally don't get in our classroom. How many cubes are there? How do you know? Throw something in the chat window for us, please. Absolutely, Kristen. So if you teach here in the United States, we tackle volume in 5th grade. But like here, you can see, like, think about how we have that volume, and you really have area, 2 times 2 times 3. Lots of different ways that we can tackle this. So the images are a really powerful way to pull out these conversations for students. Here would be the next one, getting back on that doubles strategy. And then we'd add another one. So we have 3, 6, 9, and then we would add one more for 10. So again, this image talk, this tool talk, this string of tools in a purposeful sequence really allow that storytelling and connection back to the peaches to come to the forefront whenever possible. So I've just shared like just a couple quick strings. Take a look at this screen. I want to kind of hold this up here for a moment. Look at all the mathematical thinking that just took place in the first, like, I would say in the last 15 minutes that we've been going through this 3-act task, the image talk and the tool talk. There's a heck of a lot of thinking that we can do. And I wonder, when you have conversations with students, are your conversations centered around these properties, and are they centered around these relationships? I'll throw myself under the bus and say, for too long for me, it wasn't. So it's something to kind of start getting us to think a little bit differently. And then at the very end, after we've worked through the 3-act task, through that image talk, through the tool talk. Now we give naked numbers. But what I realized is that this right here, the naked numbers, is where I started for far too long. But now when students see these numbers, they're picturing that lovely, bright, vibrant picture of peaches. So again, thinking about how we tend to start here, but really this is the back end of the reasoning. It's not the contextualized front end of the reasoning. So when I start thinking about fact fluency, I think about how all of this builds on one another. And there's a really good resource that I've leaned on a lot here recently. It's from Jenny Bay Williams and Gina Kling. It's Math Fact Fluency. And they have highlighted this beautiful progression in terms of how we can flexibly learn our multiplication facts. We're going to get to addition in a second here for our primary, but it's the same idea as well. So if you look, you have a set of foundational facts, which really falls nicely here, because a lot of the times students know their 2s, 10s, 5s when they come to us as 8 and 9-year-olds. The identity property of 1 and the identity property of 0. And then something that I love about what Gina and Jenny Bay did here is they have this squares. I'm going to sit tight for about 15 seconds. I want you to type in the toughest fact that you had to learn growing up as a student. What is the toughest fact that you had to learn or that you can remember? I think we all have one. Amy saying 6 times 7. Tammy, 7 times 8, 7 times 8. Yeah, it's funny that all of you are saying, most of you are saying 7 times 8. And research has shown that 7 times 8 is probably the research-based most difficult fact that kids must learn. But the other one I noticed was 6 times 7. So think about this. I want to make a connection to addition and subtraction. In addition and subtraction, so many students know their doubles, right? Like they know 9 and 9 is 18. They know 8 and 8 is 16. 7 and 7 is 14. But they don't know like the doubles plus 1 or the doubles minus 2 facts. So we leverage the doubles. What if we started, thanks to Jenny Bay and Gina here, what if you really focused on the squares as a foundational fact? So that when students get to those really difficult facts, the 8 times 7, well, they could use 7 7s and then another group of 7, or they could use their 8s if they wanted to as well. So again, leveraging those squares. So here you have a set of foundational facts, but then we see the double that we've already kind of chatted with about the pairs, with the peaches, and we have the distributive property. So the properties are needed. And if students don't own these properties, well, they typically revert back to skip counting, which can become really cumbersome when they get into middle school and high school. So I wanted to give you a 60,000 foot view, starting with multiplication. And now some of you are here, but it's the same idea. And we can really invite these same conversations, these same mathematical conversations into our K2 classrooms as well. And so I'm going to kind of front end load it with going back to Jenny Bay and Gina. And so here you can see the same kind of idea with foundational facts, but then you also have derived facts. And if you take a look and you teach kindergarten right now, and you're in this session right now, Kenny, I'm thinking of you. Look at the bulk of the work for building fact fluency that really falls in kindergarten classrooms. Sums within 5, plus and minus 0, 1, and 2. Doubles within 10, like 2 plus 2, 3 plus 3, 4 plus 4, 5 plus 5. Combinations for 10, 6 and 4, 7 and 3, 9 and 1, 8 and 2. And then the 10 and some more, like the teens are a beast, but yet that's where we're building that understanding. A lot of the groundwork, and as kindergarten teachers, we don't necessarily think of those big pieces of ideas as fluency. We think of it as conceptual understanding, and it really, really is, but think of it as how you're setting students up for success and the importance of context, and that should play. And then you can see near doubles, making 10, and the pretend to 10 strategy that you can see here with the derived facts. So we'd start off Same way that we did with Peaches with a 3-act task. So I'm not going to milk this out here, being mindful of time. I know it's late for those of us who are on the East Coast here. What do you notice? You're going to notice a pink mat. You're going to notice wood, a basket, green apples, red apples. I want students to get to this place. How many apples are there of each color? So that's kind of where I want to go here with this problem. And so this is the information that I would give students. There's 10 apples in the basket, and there's 2 more green apples than red apples. Yeah, comparison problem going to wreck so many students' minds, but that's great because we're not after answer getting in this moment. What we're after is how students are thinking and how they see the numbers coming together and taking apart. So 10 apples, 2 more green than red. Yeah, you can do this here. And there you can see right there from the image and everything along that line, you can see you actually have a 10 frame. You've noticed all this wonderful thinking. So now we really want to leverage this understanding here. So what do you remember? What's sticking with you from the apples? You probably remember green apples, red apples, the basket, a lot of this understanding. So now I'll come back and we want to continue talking about this mathematical story here as much as possible. So like with multiplication, we wanted to leverage Peaches for all of our 4s. Well, now for the apples, we want to kind of play around with this idea of doubles and near doubles. So here is an image that we would use. And some of you right now, there are things screaming at you. How many apples are there? Throw something in the chat window for us, please. Yeah, you're seeing 20. You're probably seeing like 4 groups of 5, or you might be seeing 5 rows of 4. You might see 10 red, 10 green. Lots of different ways to see this. And now I can come back with this one here. Don't tell me the sum or how many there are. How are you counting them? Share that in the chat window for us, please. Nice. Awesome. Checking out the chat window here. I've done this with kindergarten students, and I've also noticed that some students, where here you're all kind of seeing doubles and that part whole thinking of 20 minus 2. I've seen students go ahead and take 1 apple from the green, give it to the red to make a 10, and then they have 10 and double 4 for 8 left over. The images allow students to move and kind of move the shapes around and do whatever they want with the numbers because they've all grabbed an apple before. They've moved it, where sometimes those tools might not be as accessible to them. They might not be able to contextualize that. Then here's the next one, and then the next one. So again, we have this idea of an image talk to where we're using purposefully showing images to continue talking about that story that we were talking about with fact telling and the apples. And again, it comes back. So now that students really have this idea of apples burned into their brain, like they know apples, they've seen green apples, they've seen red apples, they've seen them in baskets. Like they know that every student now has something that they're taking with them. A mathematical residue has been laid. And now we come back with a tool talk. So we replace the apples with a tool now that students are familiar with. And you know it, that students are going to say, oh, those are just like the apples. Like that looks just like it. And I'll be like, what do you mean just like? Well, the other ones had red and green, but these ones have like red and yellow. And other kids are like, yeah, that's what I saw too. So now these are not just math tools, they're apples for students. And that's what we really have to try and be getting at, making those connections for students whenever possible. And there you have the exact same image. And again, and then again. And then there you have the image talk with the images of apples. We go to the tool talk. And then at the very end, we go right back to the naked numbers. Like this is not where we start. Now, granted, I'll be honest, in kindergarten, we don't really start here a whole lot. But in first and second grade, sometimes we start with the numbers too quickly and not ever allow students to see that that is not really a 5. It's a quantity of 5 that can be decomposed and manipulated as if it was 5 individual apples. So then the next piece here comes into games. So after you've had this opportunity for students to play with the properties, for students to play with these relationships, now they just need an opportunity to practice. And here's some of the games that I love. One of the games that I love is I hate roll and record games where kids just take a die, they roll the die, and after they roll the die, they just put the dice together and they find the sum. In this game right here, what students are doing is they roll the die and they have a choice. They can either double the die or they can half the die. So there's always a decision that has to be made. And for here with this student, if they roll a 1, can they half 1? Sure they can. They're just not going to find the number that they need if they do it. But if they roll 1, they might double it. If they roll a 4, do they want the 2 or do they want the 8? I want to put students in a place to where they're not just rolling, but they're rolling and thinking, putting students, 2 players, 2 versus 2 with games, so that when students are talking about the moves simultaneously, I can now be within an earshot to formatively assess the thinking that's taking place. So that's one way that we can do that with addition, subtraction, and with multiplication and division. Those games where students are given the opportunity for choice. But then also in 4th grade with multiplication, Open Middle is probably one of my favorite sites for building that purposeful practice. We now go ahead and get open middle problems and we build it around that factor of 4 to where now students are getting that purposeful practice that they really need to be successful with their 4 facts. It's really about being intentional. It's not just saying, let's do our 4s today, we'll do our 5s tomorrow, we'll do our 6s the next day. It's about really grounding and planting yourself in the 4s to where students have an opportunity to breathe, express their reasoning, and be okay taking risks and chances instead of trying to plow along moving forward. So just as we shared before, kind of wrapping up here, I want to challenge you to think of fact fluency as an outcome of meaningful problem solving with purposeful practice. And a lot of our curricula is set up to where we do the strategy and then we move on. We do the strategy and then we move on. There's no coherence between so many of the resources that are out there. And I invite you to try and find that coherence and build it all together so that students are making those mathematical connections in context and also out of context. I want to share this last little video. I've shared it in a couple presentations, but I always think about 2 types of teachers. There's the hair teacher, the teacher that wants to get after the facts and get them done so that they can get to the really, really meaty piece of the math. And then there's that teacher, like the tortoise teacher. I was the hare. I'd like to think of myself as the tortoise now. Which teacher are you? right? Like I want to be that hair. I don't want to be that hair. I can't tell you how many times I would, as a third grade teacher, I'd bolt out of the gate and I'd be like, yeah, we're doing all our facts. And I've got my next spring's bulletin board up in like September. What I've realized is that when I'm a turtle, when I'm a tortoise, I'm far more intentional and far more purposeful. Like it's not a sprint. The school year isn't a sprint, it's a marathon. And when I take a step back and I look at things from a 60,000 foot view, I don't have to teach things from a granular perspective. I can really try and interconnect as many ideas as possible because I've provided myself an opportunity to show myself some grace, to slow down and enjoy what it is that I love doing, which is working with students and listening to their thinking. And the best way to do that is to turn yourself into a mathematical storyteller. And I think fact fluency is an easy and accessible way that so many of us can do that. But maybe you don't know what you didn't know until you know. So hopefully this kind of helps and pushes you in that direction. So the only call to action I kind of have for you today is to build fact fluency through a context. Like, don't just say, today we're going to do our facts, and then after we're done with our facts, then we're going to do the math. No. It's all interconnected with one another. So that's kind of it in a nutshell. 4 minutes short of time. We went through 7,522 slides. Thank you so much to all of you for hanging out. I can't wait to go back and look at the chat window. All the best. I'm going to stick around for a little bit here. If there's any questions in the chat window, Lee, if I missed anything.
Yeah, I actually, if you personally click on the presenters tab in the chat, I did post a couple questions in there for you that I grabbed from the chat. I think I got most of them.
Yeah.
So, and while Graham is taking a look at those questions, I am just going to remind people that we are looking for speakers to share how the Global Math Department has impacted your teaching. We're looking for people to present for about 10 to 15 minutes on June 29th. And if you think you're interested in sharing at that session, just send an email to globalmathdepartment@gmail.com. Or I'm going to put a long URL here in the chat. You can go to this form and express your interest as well. So hopefully that was enough time to stall so that you had a chance to read the questions there, Graham.
Yeah, absolutely. So the first one is, how do you define context? I define any context as anything that is put in a real world scenario. That would be kind of like the easiest way to kind of explain that. So I would define context by anything that students can relate to the real world. That would be the easiest way that I can kind of define that. Next question. No. So the next question is, how are these outcomes significantly different than dots? So like subitizing. So the ability to subitize. Part of the problem when students are just seeing dots is they just see them as dots, and they have a really difficult time connecting those dots to contextualize problems. So even if you're using dots, switch the dots out sometimes for like cupcakes. Switch them out and try and build that mathematical story whenever possible. The big piece with the images is that students now, like, you're not going to remember a group of dots that you saw, but you will remember. I've seen that students will remember those images because they all have, like, you don't get dots in your life. The only place where you get dots in your life is in math class. So it gets a little hard to take math class outside of math class. But if you see peaches or you see apples, then you're more willing to invite that math conversation that you had in class outside of class. Yes, I will be adding. So if you want, I know it's probably going to be a lot, but I don't mind if you email me. I can definitely share some of the things that we shared today, and I can also share some links where you can find some more information on how to find some things like this here. Yeah, absolutely. I can definitely help out with that for sure.
Can you remind us of your email address again?
Yeah, everything is gfletchy@gmail.com.
Okay, I just posted Graham's email address there in the chat.
And I think I got through all the questions, Lee. The last lingering one is, will they be? Oh, I missed one. Do I like to have kids write out corresponding number sentences? I'll be honest. Do I have kids always write out number sentences? First of all, if kids can't talk the language, they're never going to be able to write the language. So for me to begin, it's more imperative that students can talk about their mathematical thinking than they can write about their mathematical thinking. I think about a lot of our English language learners. A lot of the times they know the words they want to say, but they can never say it. So providing them that opportunity to build that language-rich class. And if you can't write an equation as a 5 or 6 year old, or think about how messy it is for you as teachers writing the distributive property when you first learned it. Like, what do I do? Do I add this or do I subtract this? It's the same for kids. So talking about, well, I did multiply these two numbers first and then I multiplied these two. If they can say that, having kids articulate their thinking is really, really awesome. So I'll start there. I'll put more weight on explaining your thinking than I will about writing about your thinking.
All right. And I know some people have posted some information about additional resources in the chat. So I don't know if you have any recommendations on any good resources that are free or cheap, Graham?
Yeah, so this is something new that I've kind of tried. I know I can share like one number string. I can share some number strings. I don't have the link ready for me right now. I probably could have had that, but the big piece is this is nothing out there is really like this. It's normally just naked numbers. It's all outside of context. So it's very forward thinking in it. So but yeah, I can definitely help and share some things. If some people reach out to me, I can point them in the right direction.
Okay, great.
And then the last one is 3-act tasks. I will be adding I probably have close in the next, I don't know, maybe next 3-4 months, I'll probably have close to about 70 new 3-act tasks around fact fluency that I'll be adding to my website.
Great. All right. Well, thank you very much for being here today, Graham. Lots of interesting information, lots of activity in the chat. And hopefully teachers will have found this useful. Just to let you know, we do have another elementary talk coming up in 2 weeks, partnering with parents in elementary school math. So maybe think about some of the ideas that you saw here today about building fact fluency through virtual storytelling, and then partnering with parents in the elementary school to help them understand that there might be a different definition of fluency than what they were used to growing up with mounds and mounds of flashcards being put under their noses. So thanks to everyone for being here tonight. Just so you know, we're looking for Global Math Department webinar attendees to share how the Global Math Department has impacted their work in their classrooms. We're looking for presenters to share for about 10 to 15 minutes each. If you're interested in doing that, please send an email to globalmathdepartment@gmail.com. If in addition, if you know any potential speakers that would be good for speaking at any of these webinars, please email us or have them email us at globalmathdepartment@gmail.com. We look forward to seeing many of you at our next webinar on February 2nd, partnering with parents in elementary school math with Hillary Kreisberg and Matthew Rivenon. I think I said that right. All right. Have a lovely evening, everyone. Thank you so much, Graham.
Awesome. Take care, everyone. Good night. All the best and be safe and well.